Hey pre-algebra students, so our lesson today is called Sequence and Undo, and our learning target is we are going to use inverse, aka opposite, operations to solve two-step equations using the sequence and undo method. In our lesson, some of the main ideas are properties of equality. We're going to look at how we use them in the context of solving equations. We're going to practice solving equations the quote-unquote traditional way, meaning the way that you were taught in the past, like in 6th and 7th grade. And we are going to move into solving equations with sequence and undo. You should be following along in your notes. I have a fill-in-the-blank copy, and if you're following along with these slides, you should easily be able to work through your notes with me. All right, so let's talk about properties of equality and inverse operations. So when we think about opposite operations, let's talk about the opposite of addition. Well, to eliminate addition, to cancel it out, we have to subtract. So the opposite of addition is subtraction. And of course, the opposite of subtraction would be addition. They are opposites of each other. For multiplication, to reduce or eliminate multiplication, we need to divide. The opposite of multiplication is division. And conversely, the opposite of division would be multiplication. They are opposites of each other. Just some quick examples to explain what I mean. Let's say you have the term 3x. This just means 3 times x, or 3 times a number. In order to isolate x or get x by itself, we have to do the opposite of multiplying by 3. That would be dividing by 3. And of course, this would reduce and cancel out. If we had x minus 4, we know that we are subtracting 4 from x. To eliminate this, to cancel it out, we would have to add 4. And of course, in the context of an equation, right, you would need to add 4 to both sides. So let's use those properties of equality to solve equations the way that we were taught before. So in problem number 1, we see the equation 5 times x minus 1 is equal to 14. 5x again just means 5 times x. The goal is to get x by itself on one side of the equal sign. So let's start with this minus 1 that we see. So the opposite of subtracting 1 is adding 1. Let's use that inverse operation. Add 1 to both sides of the equal sign. This is eliminated. It's canceled out. And now we're left with 5x. 5 times x is equal to 15. Since this is 5 multiplied by x, we need to divide by 5 to reduce. 5 divided by 5 is 1. We are left with 1x by itself. And x is equal to 15 divided by 5, which is 3. And let's try one more. Number 2 says x divided by 8 plus 9 is equal to 12. Let's start with this plus 9 here. The opposite operation of adding 9 would be subtracting 9. And what we do to one side of the equation, we must do to the other side. This has been eliminated. We're left with x divided by 8 is equal to 3. 12 minus 9 is equal to 3. Now, x in this equation is being divided by 8. The opposite operation of division is multiplication. So we're going to multiply both sides of the equation by 8. These 8's reduce. 8 divided by 8 is 1. We're left with 1x. And x is equal to 3 times 8, which is 24. To check our answer, we could easily plug in these values of x back into the equation, and as long as the left side equals the right side, we know that our answer is correct. Now let's try solving two-step equations in another way, using sequence and undo. Really, sequence and undo is doing the exact same thing as that traditional method. However, it's just written in a different way. We're using kind of a linear method. So let's talk about the table itself. The sequence side of the table just demonstrates what happened to x to create this equation in the first place. The undo side is The purpose of the undo side is to undo each of the actions that happen to x in the sequence column. So let's practice. The way this table works is we are going to write the sequence of what happens to x moving down the sequence column, and then we're going to be undoing those actions by moving up the undo column. So let's write these actions out. Let's start with x, and we're going to list everything that happens to x in the equation 3 minus 3x is equal to 12. So the first thing I see happening to x is it's being multiplied by a negative 3. Remember, the subtraction sign actually means we're multiplying by negative 3, not just by 3. So times x times negative 3. X times negative 3. The next thing I see in the equation is that we are adding a positive 3 to that. So x times negative 3 plus 3 is equal to 12. So this sequence here is the exact equation, just written in a different way. X times negative 3 plus 3 equals 12. So let's take the end of the sequence column and move it and flip it into the undo column. So now we're going to start with 12. And we are going to do the opposite operation on 12 on our way up this column. So 12 minus 3, because subtracting 3 is the opposite of adding 3. When we see times negative 3 in the sequence column, we're going to actually do the opposite, divide by negative 3. So now let's work our way through this operation here. So 12 minus 3 is 9. Let's just keep a quick note to ourselves. 12 minus 3 is 9. And then we're going to take 9 and divide it by negative 3. 9 divided by negative 3 is negative 3. A positive number divided by a negative number is a negative number. This is the answer to our equation. This is the result. X is equal to negative 3. And just so I can prove it to you, I am going to plug in or substitute negative 3 for x in this equation. So 3 minus 3 times x, which is negative 3, is equal to 12. So let me simplify here. Negative 3 times negative 3 is positive 9. And 3 plus 9 is 12. So it looks like we solved this equation correctly with sequence and undo. Let's try one more. And just to remind us again, we are going to be moving down the sequence column, listing every action that is happening to x to create this equation. And then we're going to move our way up the undo column undoing all of those actions. So let me show it in a different color here. Okay. So starting with x, we always want to start with x in our sequence. The first thing I see that's happening to x is it's being multiplied by 8. 8 times x. So x times 8. And then I see that we are subtracting 10. X times 8 minus 10, and that's equal to 6. So there's all of the actions that created this table, or that created the sequence column. Now we're going to flip the sequence column into the undo column. Start with 6, that's where we left off. And then we're going to go back up and we are going to change all of the operations. So instead of subtracting 10, we are going to add 10. Instead of multiplying 8, we are going to undo that by dividing by 8. So let's keep track here. 6 plus 10 is 16. And then 16 divided by 8 is 2. So look there. We solved this equation, we wrote out the sequence, we undid every part of that equation, and we got our answer, x is equal to positive 2. There are 2 additional practice problems, and I would like you to stop here and try to solve those on your own. All right. Thank you for watching. Thank you for participating. The next thing you're going to want to do is, if you have not already, try out those additional practice problems in your notes. You can check your answers with my filled-in copy of the notes. You can find this in your class notebook in the content library, and then go to Module 0 Notes, and you can find the sequence and undo filled-in notes. If you need any support, just ask in the math help desk. I hope you have a lovely, lovely day.